Well, look at this. Sunlight, a magnifying glass, and we've burned paper. Wow, the power of light.
Hello everyone, I am Jade, and today I'm going to be talking about the electromagnetic spectrum. Before I get into the topic, first I want to share a couple facts about me. I am currently a junior at ASU studying biology, and this past summer, kind of cool fact, I got to study in Spain. So, what is the electromagnetic spectrum? A complete spectrum or continuum of all forms of light. An electromagnetic wave consists of electric and magnetic fields which vibrate, thus making waves. The entire spectrum consists of radio waves, cell phone waves, microwaves, radar waves, infrared waves, visible light waves, ultraviolet waves, X-rays, and gamma rays. And kind of like in terms of energy, your higher energy waves are going to be those gamma rays. They can be pretty dangerous and cause damage to our bodies. Pretty much everything after radar waves can. And then your radio waves are going to be the lower energy waves. What are the properties of waves? So there is speed, frequency, and wavelength. They're related by the formula speed equals frequency times wavelength. All light waves travel at a speed of about 3 times 10 to the 8 meters per second. That's pretty fast. It takes about, I think, 8 minutes for the sun to reach Earth, if you want to calculate it out. Using the formula, though, I want you all to try to determine what the relationship is between frequency and wavelength. You can go ahead and pause to figure that out for a second. All right, now that you guys had time to think, the relationship that exists is an inverse relationship. Frequency increases as the wavelength decreases. You can look here to kind of see it visually. There's a higher frequency, shorter wavelength. So the peaks are occurring more often, there's less distance between them, so higher frequency, short wavelength. Down here, low frequency, the peaks are occurring more or less frequently, so that's a longer wavelength, there's a longer distance between the peaks, and this creates a lower frequency. So as frequency increases, wavelength decreases. And then if you want to see like a little bit more of the math behind this, you can click on the link below and see a video for that. Next, we're going to talk about the visible light spectrum. I have a little experiment at the end that you can also see for this. The portion of the electromagnetic spectrum that human eyes can detect is the visible light portion. And looking at the entire electromagnetic spectrum, it is this very short, very small area right over here. And compared to the whole spectrum, like we're not seeing very much. But you can kind of remember the colors that make up this visible light spectrum. Roy G. Bibb. I'm sure you guys have heard this before. So that's red, orange, yellow, green, blue, indigo, and violet. Kind of funny fun fact, when I was in high school, my teacher told me that indigo was not a real color and that Newton made it up because the church would not have accepted 6 colors. There needed to be 7. So just interesting fun fact that I learned when I was in high school. Looking at the spectrum, red has the lowest frequency. You can kind of see that here. It's on this end over here, lower frequency, and violet has the higher frequency. So higher frequency, shorter wavelength, lower frequency, longer wavelength. White light contains all colors of the visible light spectrum, so all of these colors can be summed up to just be white light. So if we wanted to just put like a white light sign here, this would be all the colors of the rainbow, all the colors that we can see. Objects appear a certain color because of the colors they absorbed or reflect. So kind of thinking about that a little bit, like why do you think a plant stem is green? And this is because it absorbs all colors of visible light and reflects green. To see an experiment of this, go ahead and skip ahead to in this video, and I will do an experiment on color of light. Next, we're going to talk about reflection. So I'm sure you guys have all looked in the mirror and seen your beautiful selves in it. So light can reflect or bounce off of objects like a ball. But the reflection of light is how we see everything around us. The look of objects change based on different ways light is reflected. A flat mirror reflects the exact reverse of an image. The reflected light rays travel at parallel paths, so they're like running together. If you just get the direct object but reverse orientation. A convex surface, like the outside of a spoon, like a little bit of a curve, distorts the reflected image. The light rays spread out, so you might see something like a little bit bigger. Now I want you to think about what happens when an image is reflected off a concave surface, like the inside of a spoon. This can be pretty interesting. Feel free to go ahead and pause and go grab a spoon to see what you think happens. And you'll find out that you were upside down in that spoon. Now we're going to talk about refraction. So this kind of has to do with the speed of light. Speed of light is not always the same. It slows down when it moves through transparent things, so like a glass, water, oil, even like oil used for your mom or dad might use for cooking. When light slows down, it tends to change direction or refracts. So kind of like even looking here, this is what refraction is. Like literally when you have a spoon in water, how it looks like it's broken or not connected anymore, that is because the light is changing directions. This allows us to create things like glasses, so like I'm wearing right now, and to also use like the projector your teacher might use in your classroom, because the lenses are used to direct the light a certain way. So like for my glasses, the lenses are made in a certain way so that the light is refracted and directed into my eyes so that I can see things. We're going to further explore this in an activity.
Now we will continue learning with some activities. First we have the color of light activity. For this experiment, you will need colored lights, a green, red, and blue marker, a pen, and a white cup. Use the markers to separate the cup into the colors as seen. Then use a pen to puncture a hole directly in the middle of the bottom of the cup. Turn on the colored lights and then insert one light into the bottom of the cup through the hole. Think about these questions. What happens to the colors inside the cup? Why do you think the colors change inside the cup with the different lights? For the next experiment, we will look at the reflection of light. In this experiment, you will just need a flashlight and a mirror. In a dark room, hold up the flashlight and put the mirror directly in front of the beam of light. Move the mirror around and see what happens to the beam. Think about these questions. What happens to the beam as it is aimed at the mirror? What happens as the mirror is moved around? In the final activity, we will look at refraction. For this activity, you will need a glass of water and/or oil, a wide-tooth comb, and a flashlight. Set up the activity by placing the flashlight down and putting the wide-tooth comb directly in front of the beam. This should create several distinct beams. Then place the glass of water or glass of oil in front of the light beams. Think about these questions. What happens to the beams of light? Do the beams of light change direction? Where do the beams of light meet? What is the focal point? Thanks for learning with me. I hope you enjoyed the video. Feel free to comment if you have any other questions.